For question 3, we're given 3 points, points B, A, and T, and we're asked to plot them and then connect them to form triangle BAT. So let's go ahead and plot those points. B is at -6, +4, so -6, +4. This is the point B. A is at the point -2, -2. So here's A. And then the last point is T, which is at +3, +3. So here's the point T. So if I connect those, I can make this triangle, right? So roughly, I'm just going to try and connect B and A. Yeah, close enough. Connect T with A. And then go back B to T. So we've got this rough triangle. And we're asked to do a couple of things with it. The first thing we're asked to do is to find the perimeter of this triangle. And in order to know the perimeter, we have to know the length of each of these 3 sides. So the thing we're thinking of most is the Pythagorean theorem. And if I was going to figure out how long it is from A to T, how long this segment is, I know that I've got this vertical distance here, and I've got this horizontal distance. And these are nice because they make a right triangle here. I think both of these are 5 units long, right? This is 1, 2, 3, 4, 5. So that, yeah, this is 5. On this one, I can see that I'm going from 3 all the way to -2, so it's also 5 units long. So this hypotenuse would be the square root of 5 squared plus 5 squared, which is the 25 plus 25, which is 50. So this is the square root of 50. And that is the square root, your calculator will tell you exactly what that is. And for now, you can use that, but you do need to understand where that's coming from. So that root 50 is the same thing as the square root of 25 times 2. And I can break this up into 2 separate roots because it is multiplication here at this point. These are not terms. So I can write this as the square root of 25 times the square root of 2, which is 5 root 2. So this is exactly what your calculator will say. It will say this is 5 root 2. 5 times the square root of 2 is the length of that segment. The length of the other segment, let's do BA next. Again, I'm always drawing, let me put that back. I'm always drawing and thinking about these right triangles. So there's this vertical and there's this horizontal. The vertical is 1, 2, 3, 4, 5, 6, and the horizontal is 1, 2, 3, 4. So I'll go and label this. This was 6 units and this was 4 units. So this hypotenuse, right, and I know this is a right triangle because I've got here a line that has an undefined slope and a line that has a slope that's 0. So it is a right triangle. This happens with all the vertical and horizontal lines. And I know how to figure out if an angle is right also by looking at the slopes have to be opposite reciprocals. But anyways, let's just get this. This hypotenuse is 6 squared, that's one of the legs, plus 4 squared, and then I'm going to take the square root of that. 6 squared is 36 plus 16. I do have to add those together. I get 40, I think I get 52. So this is the square root of 52. And I think that's 4 times 13. I wish I had the class calculator here. 4 times 13. That's 12. Carry the 1. That's 3, 30. 4, that is 52. Yeah, so this is 4 times 13. So I can say that this is the same thing as the square root of 4 times the square root of 13. Your calculator will call this 2 root 13, and you don't have to do any work to get that. It'll show you that value. So I've got 5 root 2, and I've got a 2 root 13. The last thing I need to know is the length of B to T. This is 9 units along this top, so if I measure that, that was 9. I think it ends up at 3 and began at -6. So this is 9 units long, and this is 1. 9 squared is 81, and 1 squared is 1. So what I have here is the square root of 82, and that doesn't have any perfect squares in it, so I just leave it as root 82. So the perimeter of this is a combination of 3 things, right? The perimeter is 2 root 13 plus 5 root 2, and then plus root 82. Now, these are not pretty numbers, but if you left it that way, that would be fine. It's nice to indicate that, these are units. You don't just linear units. It's a length. It's not square units, it's linear units. You could turn this into a decimal also if you consulted your calculator and hit that button with the double arrows. It would tell you that this is about 23.34 units. All right, the next thing, it says find the equation of a line that's perpendicular to segment BA and goes through the point 4, 4. So 2 things. It says perpendicular, and I understand that lines that are perpendicular to each other have slopes that are opposite and reciprocals. Perpendicular to segment BA. So I need to figure out what is the slope of BA, take the opposite reciprocal of that to get the slope that I need, and then remember that it has to pass through this point 4, 4. So let's talk about the slope of BA first. So I can see that the sides of this right triangle were 6 and 4, but they're not really directed as a slope, right? If I'm starting at this point here and going down, that's -6, right? I go down 6 units, and then I go over 4 this way. So the slope of that line is -6/4. So I can say the slope is the slope of this line is -6 down 6 over 4, which does reduce to -3/2. So if I need a line that's perpendicular to that, right, the perpendicular slope for that would be +2/3. So this is the slope I'm going to use. And the other thing I have to remember is it has to go through this point 4, 4. So let's go ahead and figure out what the y-intercept is in this case. I'm working with y is equal to mx plus b, and if I'm trying to figure out what b is, I know that if I take a y value that I know and I subtract my slope times an x value that I know, I would get that value of b. So my y value is 4, and I'm just going to subtract from that 2/3 times the x value 4. I'm just plugging in x and y. 4 minus 8/3, right? 2/3, -2/3 times 4 would be -8/3. And if I wanted to turn this 4 into thirds, I could say this is 12/3. That's the number 4 minus 8/3. 12/3 minus 8/3 is +4/3. So my y-intercept, my value of b, is at +4/3. So I think I'm ready to write the equation of this line. The equation of this line would be y is equal to 2/3 times x plus 4/3. And as a check, if I plug in 4 for x, I should get 4 for y. And also, as I should check to make sure I have the correct slope. And I think, just being aware of the fact that when you see a line moving down as you go from left to right, it has a negative slope. So I think some of us had a problem identifying that BA had a slope of -6/4. All right, then the final question here is that we're asked to find the area of triangle BAT. And I think I saw this not often, but some. Some people thought that this looked like a right angle, and they just decided to multiply the 2 root 13 times the 5 root 2 and then take half of it. The problem is that's not a right angle. BA and TA don't have opposite reciprocal slopes, so that's not something I can use. The strategy that we're going to have to use is say, look, I'm trying to figure out the area of the triangle, and what I could do is I could go through and I can subtract several things. For example, I could subtract the area of this triangle, right? If I want to find the area of this inner triangle, I could subtract this right triangle, That's going to be easy to find its area. I can subtract this triangle, and then the other triangle I would have to subtract is this one right here. And when we say we'll subtract from what? We'll subtract it from this rectangle. So I have this massive, it's a rectangle that's 6 units tall. Oops, wrong pen. It's 6 units tall and it's 9 units wide. And when I multiply the 6 times 9, I get 54, right? So I have 54, and I need to subtract some things from that. Specifically, I need to subtract 3 triangles, triangle 1, triangle 2, and triangle 3. And if I take those 3 triangles away, what I'm left with is the triangle in the middle here. Well, the area of a triangle is always 1/2 base times height, so this first triangle is just 9 times 1 divided by 2, so this is 9/2, minus the other triangle. Triangle 2 is 5 times 5, which is 25. Half of that is 25/2, so minus 25/2. And then the last one I need to subtract is 6 times 4, which is 24, which is half of that's 24/2, which is 12, right? So I would just use your calculator at this point. You've got 54 minus 9/2 minus 25/2 minus 12. And you should get on your calculator that the area of the remaining triangle here is 25 units, and they are square units. So that's it for question number 3.